Okay, so we need a graph first. So let's get the graph. It's y equals, and that's going to be x squared minus 5x plus 4. My recommendation, if it's factorable, to factor it. And it looks pretty simple. That's x and x. And then what do you get over there? 4 and 1. And it looks like minus minus. Let's just check it. You get x squared. That's certainly true. You get plus 4 in the end. Yeah, minus 5 in the middle. And then I'm going to, what I refer to as not a great graph, but a graph that probably is going to indicate something here. So I get a y-intercept of 4. I'll write that point down. That's 0, 4. And then what do you get? You're going to get an x-intercept at 1. And that's the point 1, 0. And you get another one at 4. So let's see, 1, 2, 3, 4. Put that over there. That's going to be 4, 0. All right, this is a parabola, and we're going to have a line of symmetry that goes between this. And that line of symmetry is going to be where x is. Well, that's going to be 5 over 2. You can get that by inspection, or you could just add 4 plus 1, which is 5, and divide it by 2. Here goes my trouble. I got to do an evaluation. And so what are you going to get? I'll be very careful. I'm going to evaluate it here. And let's write this down. What do you get? 25 quarters minus 25 halves. Right, so minus 25 halves. That's minus 50 quarters. And then plus, that's going to be 16 quarters now, right? Well, I got to add that together. That's minus 25 plus 16 is minus 9. Well, I don't know, that's about here. What does a parabola look like? This over here. And again, I'm not great at drawing pictures here. All right, so we have a graph. It says that. We got a graph. Find the graph. We got that. The first member, we got that. The first member is x squared minus 5x plus 4, by the way. Determine the lowest point. This is the lowest point. Lowest point. That's the lowest point in the curve, all right? Now, of course, when I'm looking at it, I do see they've indicated that over there, and the graph, they say, is figure 62 on page 986. Let's go to that. And this is the figure over here. I want to point out there's another way of doing this. I like this graph better. It's nice and neat, but I see the same features, by the way. But I want to point out another way of doing it, and it's going to be y equals, and it's, a lot of teachers do it this way, and it's up to you how you want to do it. But they do it by what's known as completing the square. So, half of the minus 5, well, what's that going to be? That would be, minus 5 halves to square it, and that would be 25 quarters. And then they would do minus 25 quarters. They don't want to change the problem, by the way, and then plus 4. And my claim is it's the same thing as this thing over here. Now, why do they do that? They do that because then they see a perfect square, and that perfect square is going to be what? X, let's be careful here, minus 5 halves squared. And then what do you get there? Well, let's take a look at it. Minus 25 quarters plus 4 is minus 9 quarters. All right? I hope you realize that the smallest this could be as a square is 0. Right, so we actually found our minimal point, and our minimal point would occur when this first term becomes 0, and that occurs 0 when the x would be 5 over 2. And what would the y be if you plug in the 5 over 2? It would just be minus 9 quarters. We're getting the same thing, all right? And again, some people like doing it that way. You need to decide on your own how you want to do these problems over here, but we're still getting the same stuff, all right? Again, y-intercept looks a lot neater here. The x-intercept looks really neat. And this is the point we've obtained. How do we obtain that point? Well, over here, we just got a basic graph and we got the point directly from the graph. Thank you.